When I took it all in, the immediate, fast conclusion is, Denny, today is the day you're gonna die. Wow. Just imagine having that terrifying thought pop into your head while you're sitting 37,000 feet up in the air, inside an airplane that has just suffered a massive explosion and lost absolutely all physical ability to be steered. Well, that is exactly what went through the mind of passenger and DC-10 flight instructor Denny Fitch on United Airlines Flight 232.
Welcome to this explainer. Today, we're unpacking one of the most unbelievable stories in all of modern aviation history. We're going to dive into a disaster that somehow defied every single engineering failsafe, the completely unprecedented human teamwork that fought against a plummeting aircraft, and the fascinating metallurgical forensics that eventually uncovered a microscopic flaw responsible for the whole shebang. All right, Section 1, 1,000,000,000 to 1. So this whole thing began on a perfectly clear day. Flight 232 was halfway from Denver to Chicago when suddenly, with a massive bang, the number 2 engine, the one mounted way up high on the plane's tail, just exploded.
To really grasp what happened next, we kind of need to talk about hydraulics. You can think of them as the lifeblood of a large commercial aircraft. They provide the pressurized physical muscle needed to move the elevators, the rudder, the ailerons, basically everything that makes the plane fly where you actually want it to go. As the source material puts it, if you don't have hydraulics, you have zero control over the aircraft. Literally zero. You might as well pull the control column right out of the dashboard and throw it out the window.
Now, the sheer impossibility of what the crew faced here is just staggering. A DC-10 is engineered with 3 completely separate independent hydraulic systems. It's built for total redundancy, right? If one fails, no big deal, the other 2 take over seamlessly. In fact, pilots are never even trained for the loss of all 3 systems because, technically speaking, engineers believed it just could not happen. The odds were calculated at 1,000,000,000 to 1, and yet, the crew of Flight 232 looked at their gauges and saw 0 hydraulic fluid left across all 3 systems.
The massive plane immediately starts banking sharply to the right, heavily threatening to flip completely upside down. First Officer Bill Ruckards had his control wheel pulled as far left and as far back as it could physically go, but the plane did the exact opposite of what he was commanding. This quote perfectly captures that sheer terror. It's like driving a car sliding on black ice. Even though turning the steering wheel does absolutely nothing, human instinct kicks in and nobody lets go. The pilots were effectively completely helpless.
Okay, moving to Section 2, flying without controls. With standard controls completely out of the picture, the crew had to invent a brand new way to fly a multi-ton commercial airliner on the spot just to keep it from spiraling right into the ground. So they used the absolute only thing still working, the 2 remaining wing engines. Denny Fitch, that off-duty DC-10 instructor who actually came forward from the passenger cabin to offer his help, took over the throttles. He stood right there between Captain Al Haynes and First Officer Ruckards. By increasing power to the left engine while pulling back the right, he could slowly force the plane to turn, and by aggressively pushing power to both engines at the same time, he created enough lift under the wings to pull the nose up whenever they started diving. It was this crude, incredibly sensitive balancing act just to keep the wings remotely level. But this whole improvised method came with a massive secondary danger. Normally, a plane configures its wings with flaps and slats to slow down to a manageable 120 to 140 knots for landing. Well, without hydraulics, Flight 232 couldn't deploy those flaps. So to maintain the necessary lift and avoid simply dropping out of the sky, they had to hurtle forward at well over 200 knots.
Which brings us to Section 3, the impossible landing. Because they couldn't slow down, this terrifying speed meant that as they limped their way toward an emergency runway in Sioux City, Iowa, they were approaching the ground with incredibly destructive force.
The sheer physics of their descent were just terrifying. They were dropping at 1,600 feet per minute. To put that number into perspective for you, that is a descent rate faster than the space shuttle comes in to land. They were essentially corkscrewing down from 37,000 feet, unable to use brakes, unable to steer the wheels, and hitting the ground much, much faster than the aircraft's landing gear was ever designed to withstand. As they neared the runway, Captain Al Haynes gets on the PA system and gives his passengers the absolute hardest message a pilot can ever deliver. He told them to brace for a crash landing worse than anything they'd ever experienced. He later reflected on his duty with this profound thought, fully expecting to die upon impact. When they finally hit the runway, the right wing dipped. The plane slammed into the earth incredibly hard, igniting a massive fireball, breaking into several pieces and sliding upside down into a nearby cornfield.
Now for Section 4, the missing fan disc. When emergency crews saw that fireball and the tumbling wreckage scattered across the airfield, they didn't expect to find a single survivor. But what happened next shifted this from a story of utter tragedy to a story of miraculous survival and a relentless forensic hunt. Out of the 285 people on board, an unbelievable 185 survived the violent crash. And that includes all 4 pilots who were trapped inside the completely severed cockpit. It was a huge testament to the ruggedness of the DC-10 for sure, but mostly it was a testament to the unmatched, unprecedented airmanship of the crew who managed to bring a completely uncontrollable plane to a runway at all. But the NTSB investigators still had to figure out why this happened in the first place. Let's look at the mechanical forensics here. Investigators quickly realized they were missing a 400-pound, 32-inch diameter titanium fan disc from the front of the tail engine. This missing disc was the destructive force. When that massive piece of solid metal blew apart in mid-air at thousands of RPMs, it sent high-speed shrapnel straight through the tail structure of the plane. And here is the truly fatal design flaw. The horizontal stabilizer in the tails was literally the one location on the entire aircraft where all 3 independent hydraulic lines converged to actuate the elevators. The shrapnel severed all of them in a split second. The plane essentially bled to death of hydraulic fluid. Section 5. A microscopic flaw. The NTSB knew this sequence of destruction, sure, but to understand exactly why that fan disc burst in the first place, they needed to find it. And incredibly, 3 months later, a farmer 100 kilometers away from the airport found the massive disc just lying in her field, snapped cleanly into 2 pieces. The answer? Well, it lay in the metallurgy. Jet engine fan discs are forged from titanium alloys because they require incredible strength to withstand immense rotational stress, while at the same time minimizing weight. To see a titanium disc just snap in 2 is almost unimaginable. But when metallurgists cut a small section of this fractured disc, they found deadly impurities. Basically, a bad batch of titanium had allowed nitrogen and oxygen into the metal during manufacturing. This caused localized extreme brittleness, a tiny inclusion that severely compromised the absolute strongest part of the engine. So this disaster was quite literally decades in the making. 17 years before Flight 232, that impure titanium disc was forged. With every single flight over those 17 years, every time that engine started and stopped and spun up to takeoff speed, a microscopic fatigue crack initiated by those impurities grew just a tiny bit bigger. Because of its location on the disc, the crack was incredibly difficult to detect during routine visual inspections. It was a 17-year ticking time bomb, right up until the day it finally snapped. Which brings us to Section 6, the legacy of 232. Every major accident in aviation is a brutal learning experience, and the catastrophic loss of Flight 232 fundamentally altered how planes are built and inspected to this very day. The industry ended up making 2 massive physical changes. First off, the manufacturing of titanium for critical engine parts was completely overhauled. It is now melted 3 times in a complete vacuum so that any trace impurities, like oxygen and nitrogen, are literally sucked right out of the metal, preventing that deadly brittleness from ever forming. Second, hydraulic systems were redesigned. Designers added special fuse valves so that if a line is ever ruptured by shrapnel again, it immediately senses the pressure drop and seals itself off. This preserves the remaining fluid in the rest of the plane for the pilots to actually use. And that brings us to a final, pretty provocative thought. The passengers of Flight 232 lived because a captain checked his ego, trusted a stranger with the throttles, and a flight crew functioned absolutely perfectly in an impossible, basically unsurvivable situation. But as our machines become ever more complex, the balance between engineering reliability and human skill shifts. Flight 232 was a 1,000,000,000 engineering failure countered by a 1,000,000,000 display of human ingenuity. So, as aviation moves steadily toward more and more automation, which one will we be forced to rely on next time? It is definitely something to think about the next time you look out the window at 37,000 feet. Thank you so much for joining me on this explainer, and I'll catch you next time.